NVIDIA just released an AI that can pick up a controller and play video games for you. Not assist you, not recommend your next move. Play. It watches the screen like a human. It presses buttons like a human. And it can drop into games it has never seen before. The name is NitroGen. And if you think this is just a lazy gamer feature, you're missing what this really is. This is the moment AI crosses a boundary, from language to action. Because once an A, I can turn raw pixels into decisions and physical inputs, you're not looking at a game model anymore. You're looking at the same control loop that powers robots. Here's the core idea. Most game AIs in the past were narrow. They were trained for one game, one map, one rule set, or they needed special access, game state, internal APIs, or engine-level hooks. NitroGen doesn't. It sees the game through the final rendered image, and it outputs gamepad actions. That's important because it's close to how the real world works. A robot doesn't get perfect internal state. It gets messy sensors, a camera, a partial view, noise, latency. So NitroGen is basically a lab environment for embodied intelligence at internet scale. And the training method is the real trick. NitroGen was trained on around 40,000 hours of gameplay video across more than 1,000 different games. How do you get the action labels? Because most gameplay videos don't include the player's input. You exploit a niche habit from streamers, the controller overlay, those little on-screen displays that show button presses in real time. By pairing what happens on screen with what the overlay shows, the model learns by imitation, not by rewards, not by hand-coded objectives. Just, this is what humans do in this situation. That single move turns the internet into a giant demonstration dataset. And once you have that, you can build something closer to a foundation model for control. NitroGen shows competence across very different environments: 3D worlds, navigation, combat, and precise 2D platforming. But the headline detail is generalization. The paper reports that when they fine-tune NitroGen on an unseen game, it can achieve up to a 52% relative improvement in success rate compared to training a model from scratch under the same budget. That's the pre-training advantage. The same advantage that made large language models explode. A model learns general patterns first, then adapts fast. Now, let's be very clear. This doesn't mean NitroGen can instantly beat every boss in every game with perfect consistency. Even the project describes itself as research, and there are limits. It works best with gamepad-based games. It's less effective for mouse and keyboard-heavy genres. And the reality of gaming is messy. Menus, UI changes, different camera styles, different physics, different rules. But the direction matters more than the current ceiling. Because this is not about winning. It's about what becomes automatable. Think about what most players spend time doing: repetition, grinding, farming, running the same route, collecting the same drops, doing the same tasks. Games are full of labor. And NitroGen is a preview of what happens when that labor becomes outsourceable to an agent. Now zoom out. Once agents can do repetitive tasks in digital environments, you get second-order effects. In online games, automation changes economies. It changes progression. It changes skill signaling. It forces developers into an arms race of detection and design. But beyond gaming, the bigger story is that video games are perfect training grounds. They provide rich visuals, physics, object interactions, and endless variation without real-world risk. In other words, a safe sandbox for training control policies at scale. That's why this is a robotics story. Robots need the same basic capability: observe, decide, act, repeat. Gaming provides millions of examples of that loop, already recorded. And NitroGen connects directly to that loop. It's not a chatbot. It's not a reasoning model. It's a motor policy, trained from real human behavior. And NVIDIA didn't keep it closed. They released the dataset, the evaluation suite, and the model weights. That matters for two reasons. First, it accelerates the field. If the ingredients are open, thousands of researchers and builders can push it forward. Second, it normalizes the idea that foundation models for action will be a standard layer, like foundation models for language. So here's the projection. In the near term, you'll see autoplay features evolve from simple scripts into real agents that can handle messy situations, dynamic combat, unexpected obstacles, procedural environments, and new games with minimal adaptation. In the midterm, game engines become training platforms. You won't just play games, you'll train agents inside them. And in the long term, the boundary between digital control and physical control keeps shrinking. A model that learns to navigate a chaotic 3D world from pixels can be adapted to a drone camera feed, a robot vacuum in a cluttered house, a delivery bot in a sidewalk crowd. Different embodiment, same loop. So yes, NitroGen can farm for you. But the real headline is this. We are watching the birth of a new category of AI. Not models that talk, models that act. And once acting becomes cheap, fast, and scalable, the world doesn't just get smarter, it gets automated. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.